domain and range of linear and quadratic functions. So, the linear ones I want you guys to be aware of. You guys learn these technically in grade 9. I just want you to be aware of it for your homework that's going to come up. Okay? What I'm going to do is I'm going to quickly graph these two. Now, if you don't recall how to graph it, just kind of go back and maybe watch a video on graphing linear functions. It's relatively simple and it'll probably come right back to you. If you guys recall, this value here is considered the y-intercept, the b, in y equals mx plus b. Okay? This would be the m, in other words, slope. And we turn that into a fraction. The rise is -2, the run is 1. So we're going to graph this, positive 5. Our run is down 2 over 1. Down 2 over 1. So, our graph here is essentially, get this arrow. This is our linear function. It's continuous. It goes this way forever. What I want us to do is figure out what the domain of this is. So the domain of this function. Will there be any restrictions? Now, first of all, is it continuous?
No.
Yes, definitely is. It's not just a bunch of coordinates. So we start with XER. And is there a restriction? Does it stop left or right? It's going to go on forever. So I don't need to include a restriction. It's just XER. Range. The y values. Because it is continuous, we have YER. Are there any restrictions up and down? It's going to go forever. Because we have those arrows at the end. So the domain of this linear function is just XER and the range is YER. No restrictions.
So what is the immediate answer?
Sorry? The range and domain, oh, you're away when we did over this, is how far along the x it will go and how far along the y, or sorry, the other way on the x. That's the domain. And the range is how far up y and how far down y. Just go and rewatch one of the old ones, okay? Now, the second one here. This is a linear function. Does anyone know how to graph that linear function? Y equals -2?
Yeah.
It's just a straight line across what, Nathaniel? Not 0.
The y.
No. What number?
I don't know.
-2. It is a line that just goes across -2. Okay? So, that being our line, let's talk about first the domain. Is there anything going to be restricting this left and right, the domain of this function? Yeah, left and right, it stops at one point?
No.
So how do I write the domain of this? XER. It's continuous, goes left and right forever. The range is a little different. What's the range? -2. It does not touch any other value. It only goes across -2, so our range is -2. Okay? Nope. Because it's not continuous. It only has one value. The only value is at -2, nothing else. Okay? All right, finally, now hopefully you're very adept at graphing quadratics. We've been talking about it for a bit. I'm going to quickly change the y values of this to be in the tens. Okay? So this is now 100, 90, 80, 70, 60, 50, 40. And then this one's actually going to go over to 12, just for the argument's sake. Now, -2 means we move our x value to +2 and we go up 100. So here's our vertex. Okay? And it's downwards facing. I'm just going to let you know that it essentially does this and then comes down to 12. Okay? So here's our quadratic. And it technically would do this the other way too, to the value of 8. Okay? I know this isn't the prettiest looking quadratic. But this is how you would graph that. Now what I'm going to do is I'm going to attach a bit of a question to this. Let's say I'm actually on a cliff. And this is the height of how high up I am a cliff. And the x-axis is, how far, or in other words, time. I throw a rock off a cliff. Okay? If this is time, in other words, measured at 0, when does the rock first get thrown? Does it get thrown at -8 down here? No, I'm at this height of 80. I throw it when? At what time? 0. At 0 seconds, the rock leaves my hand. Okay? In other words, everything before this value is not applicable for our domain because it doesn't really exist. So this is the cutoff point. That's when I throw the rock. And then the rock eventually hits what? It hits the ground, or the height of 0. Okay? So I want you guys to recognize that this function really only exists in this area here if I attach a word problem to it. If I just give you this equation and ask for domain and range, we go over domain and range the other way like we've been doing before. But if I attach a question like I'm throwing a rock off of a cliff, well, my domain can only start at what value? 0, that's right. So my domain has to start at 0. It is continuous, so we start with XER. Our lowest value of time is 0. And what's the farthest it gets to? 12. So it takes 12 seconds for that rock to eventually hit the ground. Okay? Now let's say, what's that? If you would continue this all the way down, when you plug 12 into this, this will equal 0. Okay, if you made a table of values. You can always do it on a graphical calculator. Now, our range. What's the highest point of this rock? At 100. Okay. The highest point's at 100. And what's the lowest? Where does it get to? 0. So what is the range? It goes from, y is between 0 and 100. Okay? Now, normally with our parabola on the x, so let's say we've done it of the original one. I'm going to do it in purple. If I had just done the original parabola, I hadn't made this a word problem, it would be a little different. First of all, would there be restriction left and right? The parabola goes forever left and right. Okay? So that means that the original domain would have been just XER. And the range for this one, there's only one restriction. What's the highest value? 100. And then it goes what? It goes down from there. That means it'll never go above 100. So our range would have one restriction to it. YER, such that y is less than and equal to 100. That would be if I didn't attach that word problem to this. But because I said I was throwing a rock, we have to think logically. Well, I can't throw a rock before 0 in time, and the rock doesn't continue through the earth, right, to the other side. So we know there's starting and stopping points to that. Okay? So domain and range help us make sense of what's happening with a function, when it does exist and when it does not. Oops, wrong button.